This is the fourth in our series of videos where we are solving some heat problems. And in this particular video, we're going to take a look at this problem. How much energy would be required to melt, let's underline melt, 15 grams of ice at 0 degrees? In this problem, we are not changing temperature because all of the energy is being used to change states of matter. So we're not going to use specific heat, we will use heat of fusion. Remember, heat of fusion is for when we are going from a solid to a liquid or liquid to a solid. Heat of vaporization is from liquid to gas or gas to liquid. And now let's take a look at the problem a little bit closer. I do have mass right here. That's my mass. And they've given me heat of fusion, but heat of fusion is in kilojoules per mole. So I am going to first have to do a conversion either from grams to moles, or I'm going to have to convert this constant into kilojoules per mole. And I think what I want to do is convert grams to moles. All right, so let's take a look at the equation that we are going to use. Q equals m delta H of fusion, and all of what those variables mean is Q is heat in joules. This problem we're going to do it in kilojoules. M is mass in grams, and delta H is heat of fusion, and it's usually joules per gram, but in this instance we have kilojoules per mole. So let's go ahead and set up our dimensional analysis. Here's our given, here's what we're starting with, 15 grams of H2O, and we need to convert grams to moles. And the way we find the values that we put here, we're always going to put 1 in front of moles when we have this conversion factor. And for the molar mass of H2O, we're going to look on the periodic table. If we go back to our periodic table, here's hydrogen. Hydrogen has a molar mass of roughly about 1. Oxygen is over here, and its molar mass, if we round up, is 16. 2 atoms of hydrogen, so 2 times 1 is going to give us 2, and 1 times 16 is going to give us 16. If we add those two together, we are going to get 18 grams per mole. So that's what we're going to use as the molar mass. We'll plug that number in down here, and grams of H2O cancels out. We're left with moles per H2O, and when we divide 15 by 18, we get 0.833 moles of H2O. So that is what we are going to plug in as our mass, so that the units of measurement cancel out. And when we do that, we've got moles of H2O divided by moles of H2O, so we're left with a unit of measurement for kilojoules. So now we just need to do the math. When we multiply those two numbers together, we get 5 kilojoules.